Okay, I have one more for us to do. This one's just breaking down a couple of angles, and they like to get tricky because, one, notice that we could analyze from 2 points on the beam. I'm asking you to analyze from point A, but it could ask you to analyze from point B, and then we have to change that origin. The rotation changes for each one of those. F3 of Y would pass, that line of action would pass through B, negating it. So we really just need to be aware of where it's asking us to analyze from and what's passing through and what are my new distances to it. Okay. So for this one, we have F1, 2, and 3. And the first thing I always do with a moment equation or any problem is breaking those forces down into their components. So I would have a negative y and a negative x there, correct? And I would do 500, 3/5 there, and get what? And then I would have 500, 4/5 here, and get, and I'm going to say that's F2y and F2x, okay? And then same thing here. I would have this coming down, this coming away from. At any point where the force is making contact with the structure, that's where we're breaking our components down and making that the origin of where they're coming from. So for F3x, I would get 160 sine of 30, because my 30 is on the y-axis, meaning sine is going to be for x. And then F3y, I would get 160 cosine of 30. And so for those, I get 80. And 139. Yes? Okay. So now I have 1, 2, 3, 4, 5 forces that are all creating a moment about A, and I need to find the distance back from that force and where it's contacting the beam all the way back to A, okay? So I'm going to start with F1, moment, because of F1, I have 375, which will always be signless because I don't know about clockwise or counterclockwise yet. What is my distance from 375 back to A? And are we going clockwise or counterclockwise from A to 375? Clockwise. Okay. M, F2x. We've got 300. And what it is, distance from 300 back to A. Okay, because we have 8 and 6. But that distance is an x distance, correct? Okay, so if we're trying to get from here to A to f of x, and if we would have drawn out our line of action, what would we have seen about f2x? That line of action is passing through A, making its distance 0, okay? It's harder to see because it's farther down the line, but if you draw out that line of action and it can get to that origin and cross right through it, it doesn't have a distance, it's just creating a push or pull. Oh gosh. Okay, F2y, there we have the 400, and then that's when we had the 14 that we talked about earlier, because that is the distance in the x to get back to a force in the y. So I had, apparently I didn't feel like doing that, putting that in. Could someone tell me the answer to that? 400 times 14? Thank you. Okay, and are we going clockwise or counterclockwise there? Okay, MF3X, it is what distance from that point to A? 0.5 right here, that width of the beam. Okay, they like to be tricky. And is it going clockwise or counterclockwise? No. Okay, if it's down here, I wish I could rotate it for you. If you were to rotate your head and look at it from the positive Y, it would be going counterclockwise. And F3Y, we have 139, and its distance needs to be an X distance all the way back to A, which is 19. And I got 2641. Is that clockwise or counterclockwise? Clockwise. And then this one is 0. So I can do the sum of all the moments about A. I have negative 3,000, negative 5,600, positive 40, minus 2641. I should get a negative, but again, my math is incorrect, so someone tell me that answer. Can I get a second? What do we have? Pound, feet. And that would be clockwise. Sum of my moments about A. This is what I'm equal to. Stop doing that. And there we go. Okay. So good. Feeling confident about moments now. Hopefully a little bit more. Okay. Now we're going to move into couples. So couples are just two forces. They're going to have the exact same magnitude. They're going to be located however distance from the origin, but they're going to be headed in opposite directions. So one's going to be headed in the negative X direction, positive X. It could go negative Y, positive Y, whatever the case may be. They should be able to cancel each other out as far as forces are concerned. Okay, when we do our force analysis, sum of all the forces in whatever direction they're headed, it should be 0, but they're creating a moment. They are creating a torque about one another. So you can do these one of two ways. You can solve the usual way like we've already been doing with moments and saying, okay, here is this force, it's headed in this direction, here's my distance, doing those separately. Or if you can identify a couple in your problem, there's kind of a cheat system to it, and it's called a couple moment or pure moment. And it's going to be the moment of that couple is equal to the force or the magnitude of 1 times the distance between the two of them. Okay, so that doesn't make a ton of sense right now, but it will. Okay, so let me give you an example. Let me make sure I'm getting the right example. Let's say we have 3 pounds acting here. It's 2 feet away from A. And then we have 3 pounds acting here. And it's also 2 feet away. Okay, so if we were to be doing this like a moment problem, we would say that's F1 and that's F2, correct? If we were to do the sum of all the forces in the X, what would we get? This 3 pounds up top, F1 is headed in the negative 3 direction, correct? And then F2 is headed in the positive 3 direction, making it 0, back to equilibrium, which is awesome. Okay, but when we go to do a moment about F1, we would have 3, and its distance back to A would be 2. And when we would have 6, and is that acting clockwise or counterclockwise about A? Counterclockwise? And then what if we had MF2? We would have 3, its distance is also 2, it would be 6, and it's also acting counterclockwise. So if we did the sum of the moments about A, we would get 16 counterclockwise. Counterclockwise, correct? Okay, so instead, what we can say is we look at this problem and we say, oh, it's the same force, 3 pounds, 3 pounds, headed in equal and opposite directions, and I know that there's a distance between them, so I'm going to use the couple equation, which is the force of 1 times the distance between the 2. Okay, so I'm going to say my moment couple is equal to 3 pounds, and then what's that distance between the two of them? 4, and so there I have 12 also. Okay, and then I look relationally no longer to the origin but to one another and say, okay, if that was a wheel and I'm cranking it this way, whatever the case may be, which direction am I going? Counterclockwise, and then we get the same thing. Okay, so it reduces on steps if we can identify within the problem which two forces are doing that to one another. Okay, I'll do another example. No, if that's the case, then it's just a regular moment problem. You're analyzing those separately. But if you can see, yes, equal and opposite, then you use the moment couple equation and save some time. Okay, I'm going to add this one again.